Another day, another story. Sun. True color image taken in 2019 using a solar filter. The Sun is the star at the center of the solar system. It is a nearly perfect ball of hot plasma, heated to incandescence by nuclear fusion reactions in its core. The Sun radiates this energy mainly as light, ultraviolet, and infrared radiation, and is the most important source of energy for life on Earth. The Sun's radius is about 695,000 kilometers, 432,000 miles, or 109 times that of Earth. The Sun is a G-type main sequence star, G2V. As such, it is informally, and not completely accurately, referred to as a yellow dwarf. Its light is actually white. Etymology. The English word sun developed from Old English sun. General characteristics. The Sun is a G-type main sequence star that constitutes about 99.86% of the mass of the solar system. The Sun has an absolute magnitude of plus 4.83, estimated to be brighter than about 85% of the stars in the Milky Way, most of which are red dwarfs. The Sun is by far the brightest object in the Earth's sky, with an apparent magnitude of latest 26.74. This is about 13 billion times brighter than the next brightest star, Sirius, which has an apparent magnitude of latest 1.46. Composition. The Sun is composed primarily of the chemical elements hydrogen and helium. At this time in the Sun's life, they account for 74.9% and 23.8%, respectively, of the mass of the Sun in the photosphere. Structure and fusion. Core. The core of the Sun extends from the center to about 20 to 25% of the solar radius. It has a density of up to 150 grams per cc, about 150 times the density of water, and a temperature of close to 15.7 million Kelvin, K. Radiative zone. The Sun in the middle has an inner radiating zone and an outer convective zone. The radiative zone is the thickest layer of the Sun, at 0.45 solar radii. The radiative zone is the thickest layer of the Sun, at 0.45 solar radii. From the core out to about 0.7 solar radii, thermal radiation is the primary means of energy transfer. Photosphere. The visible surface of the Sun, the photosphere, is the layer below which the Sun becomes opaque to visible light. Photons produced in this layer escape the Sun through the transparent solar atmosphere above it and become solar radiation, sunlight. Atmosphere. The Sun's atmosphere is composed of four parts: the photosphere, visible under normal conditions, the chromosphere, the transition region, the corona, and the heliosphere. During a total solar eclipse, the photosphere is blocked, making the corona visible. In December 2004, the Voyager 1 probe passed through a shock front that is thought to be part of the heliopause. In late 2012, Voyager 1 recorded a marked increase in cosmic ray collisions and a sharp drop in lower energy particles from the solar wind, which suggested that the probe had passed through the heliopause and entered the interstellar medium, and indeed did so August 25, 2012 at approximately 122 astronomical units from the Sun. The heliosphere has a heliotail which stretches out behind it due to the Sun's movement. Sunspot. Sunspots are visible as dark patches on the Sun's photosphere and correspond to concentrations of magnetic field where the convective transport of heat is inhibited from the solar interior to the surface. Life phases. The Sun today is roughly halfway through the most stable part of its life. It has not changed dramatically for over 4 billion years and will remain fairly stable for more than 5 billion more. However, after hydrogen fusion in its core has stopped, the Sun will undergo dramatic changes, both internally and externally. Formation. The Sun formed about 4.6 billion years ago from the collapse of part of a giant molecular cloud that consisted mostly of hydrogen and helium and that probably gave birth to many other stars. This age is estimated using computer models of stellar evolution and through nucleocosmochronology. The track of a one solar mass star on the Hertzsprung-Russell diagram is shown from the main sequence to the post-asymptotic giant branch stage. Motion and location. The Sun has 8 known planets orbiting around it. This includes 4 terrestrial planets: Mercury, Venus, Earth, and Mars, 2 gas giants, Jupiter and Saturn, and 2 ice giants, Uranus and Neptune. The Solar System also has 9 bodies generally considered as dwarf planets and some more candidates, an asteroid belt, numerous comets, and a large number of icy bodies which lie beyond the orbit of Neptune. Celestial neighborhood. Beyond the heliosphere is the interstellar medium, consisting of various clouds of gases. The Solar System currently moves through the local interstellar cloud, here shown along with neighboring clouds and the 2 closest unaided visible stars. Galactic context. Diagram of the Milky Way with the position of the Solar System marked by a yellow arrow and a red dot in the Orion arm. The dot roughly covering the large surrounding celestial area dominated by the Radcliffe wave and split linear structures, formerly Gould Belt. The Solar System is located in the Milky Way, a barred spiral galaxy with a diameter of about 100,000 light-years containing more than 100 billion stars. Thanks for watching.